Have you ever tried to coordinate an event with friends scattered across different time zones, each relying on their local clock, and ended up with confusion about who did what, when? Well, distributed systems face a similar, far more complex challenge when their individual components do not share a perfectly synchronized global clock. The primary implication of lacking perfectly synchronized shared clocks in distributed systems is the profound difficulty in establishing a consistent, global ordering of events. This leads to issues such as inconsistencies in data, challenges in maintaining data integrity, and significant hurdles in achieving consensus among different parts of the system. This challenge arises because each machine in a distributed system has its own independent clock. These clocks naturally drift over time, even by tiny amounts, due to variations in their crystal oscillators. Without a common time reference, a machine might record an event happening before another, while another machine records the opposite, creating conflicting information. This makes it incredibly hard to determine the true sequence of operations, which is fundamental for many critical system functions. To mitigate these issues, distributed systems often employ various strategies instead of relying on a single, perfectly shared clock. Techniques like Network Time Protocol, or NTP, help synchronize clocks to a common external source, reducing drift. Furthermore, logical clocks such as Lamport timestamps or vector clocks provide a way to establish a causal ordering of events, even if their physical timings are not exact. These methods don't perfectly synchronize physical time, but they help define a consistent order of operations. Understanding these implications is crucial because it informs the design of robust distributed algorithms. Concepts like causal consistency, where events that are causally related are seen in the same order by all processes, become paramount. Without a global clock, engineers must carefully consider how to ensure that dependencies between operations are correctly managed, even across geographically dispersed nodes. This focus on causality over absolute physical time is a cornerstone of reliable distributed computing. Ultimately, recognizing that a true shared global clock is often an impractical or impossible ideal in large distributed systems helps us build more resilient and trustworthy architectures. By understanding the challenges introduced by clock drift and embracing techniques that establish logical order, we can design systems that handle massive scale and complexity while still maintaining data accuracy and operational integrity for all users.
If this helps you code smarter, like, subscribe, and stay tuned for more.